Welcome to page 2 of your probability packet. On this page, we have a learning target that states, I can calculate the probability of a given event, a single, simple event, like rolling a cube. Let's take a look at our probability scale for a moment. Remember, when you're here on the probability scale, it's a 0 probability, 0/4, 0, or 0%. When you're on the other end, we have a probability of 1, 4/4, 1, or 100% chance of occurring. The middle is an even chance, and then close to 0 is highly unlikely, and close to 1 is highly likely. Now that our scale is completely labeled and we have important increments in fraction form, decimal form, and percent form, we can calculate some simple probabilities. We're going to roll a number cube once. Let's calculate some probabilities. Work at the bottom of your page. We are going to roll a 6-sided cube once. Let's take a look for a moment at our cube. We know that the possible outcomes on a number cube would be 1, 2, 3, 4. We could roll a 5 or we could roll a 6. Even though we can't see all the sides in the picture, we know they exist. Please draw this pool of elements on your page. Each outcome in the pool has the same chance of occurring. Let's do a simple probability, like what's the probability, please write down these notes, of rolling a 6? Well, we know that there's one success, a 6, 1 out of 6. As a fraction, it's 1/6, but divide and convert it to a decimal, then multiply by 100 to convert it to a percent. Please grab your calculator and punch in 1 divided by 6. Pause the video, and when you're ready to check your work, turn it back on. You should have gotten 0.1666 repeating. And when you multiply by 100, it moves the decimal 2 places. It's 16.6 repeating percent. On the probability scale, it rates about here. The chance of rolling a 6 is not very high. Let's try another one. On a single roll, what's the probability that someone will roll a number greater than 4? Look at your pool of elements and think about how many numbers are greater than 4. 6 is greater than 4. So is 5. There are 2 successes out of 6, and that reduces down to 1/3. But convert that to a decimal. Grab your calculator and divide. Pause the video, and when you're ready, turn it back on. 1 divided by 3. You should have gotten the decimal 0.333 ... repeating. And when we multiply that by 100 and convert it to a percent, it's a 33.33 ... On the probability scale, that's right about here. A greater chance than our first problem, but still, our chances are not very high. Let's try another one. Let's say you're a winner if you roll not a 2. Any number will be a winner except for a 2. So we want to roll not a 2. Well, let's look at our pool of elements. 6 is not a 2, neither is 5, neither is 4, neither is 3, and neither is 1. There are 5 possible successes out of 6. Divide and convert that to a decimal, then multiply by 100 to get a percent. Pause your video and turn it back on when you're ready. You should have gotten 0.8333 repeating. When you multiply by 100, scoop, scoop, you should get 83.333 repeating percent. On the probability scale, that's up above 75%, right about here. Your chances are pretty good. Let's try this one. What's the probability of, on a single roll, rolling an 8? Well, if you look at your pool of elements, there isn't an 8. That would be a 0 out of 6 chance, 0 or 0%. The chance of rolling an 8, well, it's impossible. That puts us here on the probability scale at 0. Let's try one more together. What's the probability of rolling not an 8? Well, if you think about it, 1 is not an 8, neither is 2, 3 is not an 8, 4, 5, and 6 are all not 8. That would be a 6 out of 6 chance, which is 1, and when you multiply by 100, that's a 100% chance of occurring. It is what we call certain. And that puts you here on the probability scale. Please make sure you have all the notes. This concludes this page.